Well, this is Old Electronics Fan, and this is part 2. It's been a while since I did part 1, so if I repeat myself, just bear with me. In this part, I want to identify where the tubes live in the radio. My previous radio, like this, my R52, identified which tube was where. They had the tubes numbered on the schematic, and they had them numbered on the picture that showed you where everything was on the radio. As you can see, I've had to add numbers on here to tell me what is where. That's very helpful when you're trying to troubleshoot, to know which tube you're dealing with and where you're looking on the radio. The other reason that I wanted to know that was because I don't have enough tubes to fully populate this radio. One of the 26s is bad. It has an open filament, I believe. So it probably would have been fairly simple to look at where this is and see. Actually, let me back up. This is why I did that, and why I probably didn't need to do some of what I did. However, I did. For some reason, I didn't think of the quick and easy solution to not having all the tubes. My first thought was I'd populate the first 4, because I don't have 5th 26 tube, check to see if I have a working radio up to this point, and then shift that tube to here, and then try to feed something into it to see if it's working. Not the best idea. It wouldn't get me really where I wanted to go. And one of the reasons for that is the antenna, the volume control, and this is a choke coil. This is the antenna coil, I guess is how you could identify it. All of this lives on the grid of tube 1. So what my original idea of starting from here and checking forward wasn't going to work. It wasn't going to be a good thing to do. So what I did was, finally dawned on me, the simple thing was, well, you got a grid connection here. Why not just jump between here and here and basically bypass this tube socket? And that should work just fine. I won't have the same amount of gain, but I will have, I'm moving a little bit closer. Alright. I will have a completely working radio with everything I need on the front end. Because again, this is the volume control. I'm assuming that they put that choke there for a reason, and the antenna coil there for a reason. I guess it's part of this whole tuned circuit business. So, how did I figure this out? Well, as I was looking at, how did I figure out where each tube was? Well, it wasn't terribly hard. I was making it more difficult than it needed to be. So how this works. Now, tube 1 is pretty easy to identify. If you have the metal cans off, there's metal cans on the bottom of the radio, and I'll show you those in a minute. If you have the can off, all you have to do is look for a tube that is connected to the antenna wire, that's how I first chased it down. But then you also look for a tube that doesn't have one of these coils, these RF coils on it. And the way this is set up is each tube has the coil, the RF coil is set up, the RF coil, I guess, both primary and secondary, that is fed from the previous tube. So this tube has this coil, this tube has this coil, and so on down the chain. So once I realized that, it was pretty simple. Pin 2 is the plate. Now, this is going to be helpful in the future for some of what I want to check out on this, but this goes to the primary. This plate goes to the primary of this coil assembly, this transformer, whatever you want to call it, and it goes down to the B+ line right here. And so all you really need to do is follow the plate connections from one tube to the next, and you very easily find out what tubes are where. And you can see that, unfortunately, and I don't know why they did this. This is the 27 tube. For some reason, that's tube 5. I started out assuming that this was numbered like my previous radio, which was 1, 2, 3, 4, 5, 6. Don't know why they did this, but they didn't do it that way. Who knows? And maybe it's because of how they have them arranged on the radio. I'll show you that in just a moment. But in any case, so let's slide this out of the way and bring this over here. We have to back up a little bit. All right. So let's put some light on here. I guess it seems to need it. Seems somewhat dark. Well, I'm forever dropping stuff I don't want to drop. All right. Okay. Now, this is tube 1. This is tube 2. And it's pretty simple. So I'm assuming this right here is the antenna coil that we spotted earlier. And it goes straight to the grid, and grid is pin 3. Is that right? So I gotta think backwards because I'm looking at this from the top. Just a word to the wise: when you're working with these radios and you wind up looking at wiring from the top, if you're used to, when you're looking at it from the bottom, you're used to numbering the tube pins clockwise. But when you're looking from the top, you have to number them counterclockwise. So, let's see. I gotta look at it too. Get my head straight here. All right. So that pin is going to be pin 1, which would be that one, and that would be pin 2, which would be, yes, that works. All right. All right. So you'd think I'd remember that, but I don't. All right. This is pin 2. This is pin 1. These two are the grid, are the filament connections. This is pin 1, pin 2, pin 3, pin 4. Pin 2 is the grid of this tube, and this is the input from the antenna and the volume control actually in the antenna. But notice this. This plate wire is going over here and it's going down here to this. This is not a connection to the tube itself. This is a connection that runs down to the coil that sits underneath here. You'll notice that this socket doesn't have any of that. This one has 2 straps that connect to the coil that's underneath this. So, like I said, this is pretty easy. Tube 1 goes following the plate goes here. Tube 2, this is the plate again, and so on. So you follow the plate connections, and then you can very easily figure out which tube is where. And, of course, I also know, as a result of following those wires, that I can connect this. I know that this is the grid, and we connect that down here to the grid on this tube. Interesting. I think that is actually the grid. Not sure why. Oh, this must be tied to that. Anyway, so that's how I figured that out, and you can see underneath, these are the shield cans, which are very, very important. You want those on your radio if you want it to behave properly. So, back to this. Now, let's take a quick look, because we're going to be looking at, because now that I've actually got this playing, I applied power to it after I got everything hooked up. This tube was shorted with that jumper I was talking about, and the radio does work. Anyway, but we're going to have to get into some B plus stuff in this area, and I want to explain how this is. It took me a little bit of time. Number one, this is not great. This is all very small and not entirely clear. So I actually had to come down here and write the numbers out, and even then I still made mistakes. But anyhow, so the B plus comes from this line right here. That's a pi circuit. This is filtering. I believe this is also filtering for the second B plus line. I'll show you that in a minute. So the B plus comes out here, goes down here, over here, up here, and goes into the field coil. It comes back out, goes over here, goes up again. This is where it gets filtered again, apparently. Up to here, B plus goes through the interstage transformer into the plate of this. Goes over here. This is called an input transformer. Oddly enough, that's what it is. And the B plus goes through this coil, and the primary goes here. This is the radio record player switch. If it's in radio, then the B plus goes up here into the plate. Of course, that's also where your audio signal is, because this is audio now at this tube. I think it's a detector audio tube. So from this point forward, you've got audio, and then audio feeds back in here and just feeds into the audio amp. Now, when I was playing with this, I had this, since this field coil was toast, I had this disconnected. And I thought, well, I can just check the voltages on this without that. I don't need that. I didn't realize that this was kind of important. I didn't realize the B plus. I hadn't really spent the time on this to figure out where everything was coming from and going to. So when I measured the plate voltage on this and there wasn't any, I said, huh, that's not good. And then so I started tracing the lines and realized why that wasn't there, and I had to do stuff here. So this, in part one, I think you probably saw how massive the field coil was in this. And I was trying to guess at what kind of resistance this had. Typically, well, I'm thinking field coils can, my memory may be a little bit off, but I think they could range between, say, 900 and 1800 typically. The ones I've dealt with most recently are in the 1100, 1200 range. So this, however, looked like it was a lot more, and it was, as it turns out. So, all right. So I don't want to forget where I was going with the B plus stuff, because this is we'll need to know this for the future. You notice that this splits right here. This is the B plus feeding this part of the radio, and that. This feeds just the 45 tubes. Typical goes up through the output transformer primary and feeds into the plates of both of these. And so I need to figure out what to put in place of this dead field coil, so I can put another speaker on here. When I found out the speaker was dead, I was a little bit discouraged and rather disappointed, to be honest, because I was really hoping that that was good. And after some thought, I decided that I would indeed continue forward with this. But that was, like I said, rather disappointing. So I've got to figure out what that is and measure the voltages, and so I can figure out, or so I can get this properly working. And like I said, I do have it doing radio things. So initially, I've got it kind of close to where I want it to be. So, so next we're going to be going to the amp. I think I'm going to check some voltages there just to confirm that all is well. So let me just get this out of the way. Alright. So there's our radio, or amplifier rather. My amalgamation of resistors here. Let's see if I can arrange these in a way where they're hopefully not going to short out somewhere that I don't like. Okay, that goes there. Alright. I really do need to get a high wattage decade box, resistor decade box, but it won't be today. I'm not sure, given what it depends on what they want for them, whether I get one or not. This is a low budget hobby for me. I don't make any money off from this, not yet anyway. So, I measured this connection here. I thought it was 4.7. Okay, it reads out 4.6. So I don't know if the voltages are going to be what I want them to be, but the plate, this is a 26 tube in the amp. The plate voltage here should be around 100 volts. I think it says 100 volts. The plate voltage on the 26 tubes over here in the radio, I'm pointing to something you can't see, but over in the radio, the 26 tubes there are 105 volts supposedly. It's really kind of interesting because, well, alright, let's fire this up. Oh, actually, so I don't forget. I mentioned, that's a 26. I mentioned that this is a 71A, and as I expected, because this has, I think it's 5 volts. Yeah, I'm pretty sure it does. This is a 5 volt tube. 45 is a 2.5 or 2.2, what is that? I'm forgetting everything. This is not good. It's got to be on this one. I should know this, but I didn't remember. Filament on the 45, 2.2, it's a 2.5 volt tube. Apparently they're trying to be a bit conservative with their voltages that they run these tubes at, because I think the other 2.5 volt tubes, they're running at 2.3 volts. In fact, they get really precise. It's 2.35. Gotta have that 0.5 in there. I think speakers hooked up. Yes. Put this on here. So what I'm going to do right now is turn it on. Let's do that. My light is on, and I want to check voltage. So I don't remember. You notice I'm using this meter. My other meter is working. I had to put. Well, there's a little bit of hum. I don't know if you can hear it, but there is.
And a pad of paper.
Oh.
The debate happens June 20th
I had this tuned to
in Atlanta. Negotiators.
This is tuned to our local radio station, and it sounds really good. So I'm missing that tube. I did put the second 45 tube in there. I had all these cans off, and on this station, you get to a certain spot in the volume control, and it would warble and squeal and rumble, and I wasn't sure if I was dealing with an actual fault in the radio or if I was dealing with a, move this out of the way, the problem that's caused by these cans not being on there, and it turns out that was the issue. I better not play that for very long. So it's got a really nice bottom end. It doesn't sound quite as good as it was.
The unmistakable sound of the Spinners and their number 4 hit from 1973. Could it be a Falling in Love? The Spinners have a long list of hits.
And one thing that this station seems to constantly have and they've never fixed it, is it seems to have a low level hum. And I guess that station is not in a highly profitable market, so I guess they have decided not to fix that problem. They haven't in all the years that I've been hearing that. It just continues on. This is the fun stuff that you deal with when working with old vintage stuff that's been left. Yeah, I think this is what I want. I'm going to take this cover off because I want to show you what I ran into. In fact, there were a couple of things I ran into that I had me guessing a little bit. This is an example of how a mechanical problem will mimic an electronic problem. And let's see. I guess we'll do it this way. Can I do it that way? Maybe? Alright. Is that going to work the way I want it to? No. Ah, I knew you were going to do that. Don't. I can probably see that alright without. Alright, let's snuggle on in here and I'll show you. Yes. Now, there's a couple things I want you to see. Let's do this. Because I want to swing this around a little bit. This is something else I want to show you. I'm going to back off a little bit because now I'm too close. Now, all of these behave the same way. One side, let's see, is this the one? Yes. Alright, so one side, when you pull on it, the whole thing moves. The other side does not behave the same way. And I'll show you why that matters in a minute. So, again, I can't remember where I recorded this. Well, I think I may have mentioned this in part one. I'm not sure. These little rods look like circuit board material, kind of. And one of the problems that they have, or can have, and maybe on my tooth I don't want to do that, is they can become oval. They can be worn. And it's not hard to make these and replace them, because you sure aren't going to find replacements. So I did see somebody who did that with their radio that was more heavily used than this one apparently, although all the tubes in this have been replaced one time or another. And that's been replaced. There's been other parts that have been replaced. So this radio was used a fair amount. So anyway, back to my point. This what was I looking for? Oh yes, okay. Let's get in here. In fact, I'm going to use the tuner if I can. This, whoops, this right here. In fact, I'm going to see if I can swing this a little more so it's better in camera. Kind of. This right here is a coil of wire. And let's see if I can operate this so that you can see it in action. Where are you? So that coil gets larger when you tune toward the upper end. It gets smaller when you turn to the bottom. What I ran into was this coil was, well, obviously it no longer looks like copper, and that's what I believe it is. The dust and the dirt and the, I guess you'd call it corrosion, that built up on this caused this to not move freely enough to allow this to go all the way back to where it's supposed to be. And I'll show you how I discovered that. Okay. Let's look down here. Yes, I think that'll work. Well, there's a roller here, 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 and here. Now watch when I move this. See those rollers move, turn? That's how they're supposed to behave. And you notice that that these travel in, and then when you come back out, they travel out. When I was playing with my AM transmitter and I was down in this portion of the dial, I noticed that it didn't want to move, and I had to push on it, on this bar, to get it to move where it's supposed to. So, well, that's not good. So I put a little bit of oil in the center, and I oiled all of these. And as I continued to play with it, I noticed something. This wheel wasn't rotating at certain spots, like toward either end of the tuning range. I think it was at this end. And it wasn't turning because this wasn't coming all the way back. It was sitting away from that. If I shoved on it, or if I pulled out on it and let go of it, it would stay out here quite a bit further than it should be. But if I shoved on it, it would eventually touch. And what it was doing was these were getting stuck, and they were no longer tuning properly. And if you get one of these and you start pulling on these as you're listening to it play, you will hear what that does to the tuning of the radio. So this radio went from playing really well to playing really poorly, and I thought, what's going on here? My first thought was that something was failing, that, maybe a tube was going, or I wasn't quite sure what. But when I spotted that, I decided to deal with this first, and as it turns out, that was a smart thing to do, because between fixing this and putting these covers, the covers on the bottoms of this, I mean, just fixing this made a huge difference. But putting the shields around the coils also brought this thing back to working the way it's supposed to. And I wasn't surprised by that. I kind of expected that, really, because those shields are there for a reason. On the newer R35, I think, they have different tubes. I think they're 24s, and they have shields covering the entire tube on all of the tubes in the front end of the radio. And you can play that radio without those shields, but it sounds a lot better once you put them back on. Again, it's the same kind of deal. If you don't have the proper shielding, the radio's going to play like garbage. But this could have you scratching your head and chasing electronic gremlins, when in fact it's a mechanical problem. And it really was a simple fix. Just I went around to all of those. There's actually 2 coils on each of these. Wait a second. There's one here and there's one over. Oh, grr. Right here. Let's swing this around. So you see this wire right here. That's one of them, and hiding under here, that's the other side. But so there's 2 on each of these, and so you want to, if you have this problem, you want to put just a drop of oil on both of these. And once I did that, all of my problems as far as the tuning went away, and the sound quality improved greatly. And this is the final cure, putting the cams on there. But if you, like I said, if you have one of these, check these pieces of fiberboard, whatever they are, and make sure. And you can play with these and try to get a sense of how they're behaving. And there is a spring that takes up some of the slack, that because these aren't super tight, the tolerances are kind of big. The tolerances are kind of big. Oh, gee, you can't see where I'm pointing. Let's go there. The tolerances in this fiberboard are kind of, I mean, they're not huge, but there is. I'm actually able to wiggle that a little bit. And that's because just a little bit of room inside the hole that they drilled in this fiberboard between that and the post. that this is connected to. But with the spring putting tension on it, that's not an issue. As long as this part is moving freely and those coils aren't getting bound up, it's surprising how it went from sounding good to sounding horrible back to sounding good again when I finally, when I figured out what was going on. I was really amazed and pleased, actually. That was a very simple cure. And it didn't involve any parts, which is good. You're looking at nothing, aren't you? Sorry. All I did was put the nuts in that case, which you missed. Exciting stuff, I can assure you. Kind of shocked with how well that little amp works. And I stole a 45 out of one of my other radios. But this was actually sounding pretty good with just one. Because I took the 71 tube out just to see, and with the 145 in there, it actually sounded pretty decent. Although I didn't compare one to the other. And it's possible with both of them in there, I got more bottom end out of this. And I am feeding it into a modern speaker, so you need all the power you can get. Well, this is, what shall I say? I guess this could be what you call a sidetrack or something. I wanted to get, first of all, I wanted to get the speaker working that came with this radio. I tried. It was working at one point. It made me, my concern was that it went from not working to working, and I fully expected it to go back to not working. And so I took the covering off from the coil. I was getting megohms of resistance the minute I took the cover off, and after that it went downhill from there. So I thought, well, I've got this speakers from the American Bosch radio that I've got. I thought, well, maybe this one, there's an option, there's a hope for this. Well, there isn't. There is not. I guess, going close here. Can you see, oops. I don't know if you can see that little blob of corrosion. If that was the only place that existed, it wouldn't be a problem. However, let's see. Can I get more light on that, maybe? Let's see. I don't know if I can get in any closer. Let's see. Can we? Let's see. Alright. It's not great, but what you're seeing right, there's ringing here, 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 here. And when you look at this, yeah, right there. There's green all the way along through here. And this one, but the wire was running, I don't know if you can see the little green line right there. The wire was running across here, it came over here, and I think that one was here. And you can see where this was living, because you see the corrosion there. And so I was trying to measure resistance, and the wire broke off in this area, which obviously we can see why. It had been corroded right through. Here's the bottom line for this. This was stored into a place that was very damp, and I'm surprised things weren't worse in that radio than they were. So this winding, this winding is no good. I'm pretty sure the reason that I'm getting meg ohms of resistance instead of k ohms is that this wiring, and this is just one spot, has been corroded through, and now the wire is very thin. Because it's so thin, the resistance in those areas is higher than it should be, a lot higher, and so that's bad. Now, I am exploring the possibility of rewinding this. Well, I'm sticking this part in. I heard this little voice in my head say, hey, you should really check to see what it would cost to rewind one of these before you finish recording. And as I frequently do, I ignore that little voice. She's frequently smarter than I give it credit for being, and I didn't do it. But I said, you know what? Ultimately, I think I do need to do that. This little coil is 9 pounds. I'd have to buy a 10-pound coil of wire, and that coil of wire I've used Remington Industries wire in the past, and I like them. They seem to be good quality. From them, this little coil would be $180. This radio isn't worth $180. It's got a huge cabinet. It's heavy. A lot of people don't want it. It's just an AM radio. So if I were to wind it get a 10-pound coil of wire and rewind this, and I think I am going to get a winder, but I want to experiment. Because what I want to do is, and I don't have any clue how well this is going to work out, but yeah, I'm betting that 95% of this wire is fine. That's my bet. So my goal is to unwind this wire onto another coil, and I'm no doubt I'm going to find spots where the wire is going to break. So my thought is that I might, depending on how bad the area is, take out that section of bad wire, solder it back together, coat it with something to keep it from shorting out with anything else, and see how much wire I wind up with. Right now I have no idea what the resistance of this coil is because I get meg ohms instead of k ohms, which is what this should be. I'm guessing this is around 1100 ohms, somewhere in there. It could be lower than that. It could be 900 ohms. I don't really know. But if I'm able to recover most of this wire, I might then buy a small coil of wire to try to make up the difference. And then I can get that speaker working again, and I could use it with this radio with an additional resistor, because this is going to be nowhere near the size, or the resistance I should say, power size, that the speaker that came with this that is, because that's 2.9K, and this is probably less than half that, somewhere around there. But 9 pounds of copper, 180 bucks, somewhere around there. I might be able to find something for as low as 150. I always worry about that, because if the enameling is crap, then the coils can short together where the enameling is bad and reduce the resistance, and it won't perform as well. But anyway, so that is the story on this. So there's a good possibility that I'm just going to have to put a resistor in here like I was thinking of doing and call it done. Okay, well, continue to play around with this. I think Now, I think I forgot to talk about the speaker that came with this radio. That speaker started working, then I dug into it because I thought there was something wrong with it, and it stopped working. And the American Bosch coil, I think, showed me what's wrong with the coil in the speaker for this. I believe corrosion had gotten into the coil of that one as well, and that's why it's misbehaving. What am I doing? I am trying to come up with the correct resistance to replace the field coil in this radio. And the field coil on that speaker is abnormally high resistance, which means that even if I were to get a replacement, or if I were to get that American Bosch speaker working, I would probably have to add a resistor to the circuit to make it what it's supposed to be. So my goal is to come up with a resistor that will allow me to replace the field coil. Now, I've just told you that the resistance of the field coil that came of the field coil for the speaker that went to this radio was 2.9 k ohms. So why am I not just ordering that resistor? I am not automatically going with that 2.9 k ohm resistor because the voltages I get when the rheostat is set to the same ohms or to the same voltage, so to give the same voltage across where the field coil would be connected, the voltages are higher than I want them to be. Higher than they're calling them out to be, let's put it that way. So that raises a concern. I don't want to overdrive the tubes. I don't want to cause any problems for the radio. And I really don't know why putting the right field coil in the circuit which gives you the right resistance and the right voltage drop, and that's how I know that it's the right resistance, across the coil would wind up with the voltages being that much higher than what the documentation calls out. And there are a number of things that just don't add up. So I'm playing around, and you'll see in it shortly that I've actually come up with a way to figure out whether or not the tubes are being overdriven and whether or not I can safely run these even though the voltages are higher than they ought to be. I've got a rheostat here. This is a 5 k ohm 25 watt rheostat, and I just stuck it in this box so I have an easy way to handle it. And it's going to get hot, so I don't want to be holding this thing while it's getting very warm. And of course I don't want to touch the high voltage when I'm dealing with that. So, and by the way, I went with 5 k ohms because I want to have this a fair amount of flexibility. Higher ohm rheostats would not work well if I'm adjusting it down near 100 ohms, adjusting them down near 100 ohms. This one will allow me to reasonably well control the resistance setting in that low ohm range. And I'm sure I'm going to run into other radios where I'm replacing a selenium rectifier or whatever. Maybe a rectifier tube's gone and I'm just going to replace it with a selenium rectifier, or not selenium, a silicone. Having something like this makes it a whole lot easier because you can just rotate this, look at the voltages that you want to monitor, and you will very easily be able to come up with the right resistance to work with the new component, the new diode that you put in. So this does get rather warm. I have played with this a little bit on this radio, and yes, it gets rather warm. So I'm going to turn this on, and this one is this is talk. I'm watching the current that's going through this rheostat with this one, because I know what this is rated for and I don't want to exceed it. This one is going to be the voltage across what would have been the field coil, across this rheostat is where this is connected. And then this one is right now connected to pins 9 and 10, which is where I get the plate voltage for the 26 tubes that are in the radio part. And so let's fire this up. I'm going to boost this up a little bit, and then we'll go from there. I think we're good. Alright, so as I said, the voltage, and when that speaker was working, the voltage across the speaker was what the documentation said it should be. And so that's 225. This is rated, this can handle 70 milliamps of current. Right now we're at 55. Let's see if this is now playing.
Door. The National Hurricane.
Yeah, there it is. It's working. I accidentally turned it up louder than I wanted to. Okay, so that's actually not bad. Am I okay? Well, this should be, I've got this up here set to 120. That should be reasonably close. So right now, actually I'll do that right this moment. Let's go to here, AC, let's see what this says. Come on. 121. Okay. Let's bring it back a little bit. Oh, it moved on me. It went up. Close enough. Alright, so now we're going to go back here, cue back up. Alright. I want to have the voltage that this is probably going to be used at, close to that. So I have some idea of what that is. So this is really not too bad. Alright, I'm going to change, this voltage is the one that would be across the field coil. So we're going to adjust our resistance, and we're going to bring this down to 185, which is what that's supposed to be. And that if I had the original speaker, that's what it would be, because I checked it, and that is what it is. Let's see, come on. So 185, so now we have this. This is the plate voltage for the 26 tubes, and that's at 143. I doubt, let's see, I don't know if my tube manual will give me much information about those. Those are considered obsolete. Plate volts 180, grids minus 14. Well, okay, so the 26 tube can handle 180 volts according to the tube manual. And oh, I want to mention something else. I've been debating about where I should measure the voltage, because they give you voltage information on the voltages in here, and but they don't tell you, they really don't tell you where you should measure, because you have two choices. You can measure between cathode and plate when you're measuring plate voltage, or you can measure between chassis and plate. When it comes to the 45 tubes, you don't want to measure between chassis and plate, because there's a 40 volt bias voltage that gets, if you measure between chassis and plate, that 40 volts of bias is going to be added to what you're measuring. And so it's going to seem like your plate voltage for your 45 tubes is way, way, way too high. And it's not really. So for the 45s, I believe the measure between cathode and plate is going to give you a more accurate number than if you measure to the chassis. Now, what's interesting about these is there's a chart that gives me voltages, and it tells me to measure between pins 9, let's see, what was it, pin 9 and 13, I think. Let me see, that is 13, 11, 11 and 9. Because this is what, 15, 13, 11, and 9. So that's where that is hooked up. What's interesting about that is that pin 9 actually goes to chassis ground. So I'm measuring the plate voltage on 26 tubes between plate and chassis ground. And that's where they tell you to look. And they say this should be 105 volts. And this is the correct voltage that's the voltage you would see if you had the original speaker plugged into this radio. So it's a little bit puzzling that it's so far off. So I'm of two minds, because this is almost 40 volts higher than it's supposed to be. But again, the tube, and I don't know if it tells me, that told me what current. I'm just curious to see if this gives you, this tube manual is from 1960s, and so it treats the tubes in these old radios as obsolete, of course. And let's see, 1.5 grid voltage plate, 6.2 milliamps. I'm not sure about that still. However, if I want, part of this is I'm not going to be running this all the time. That's not going to be a daily driver or anything like that. But let's see what happens when I bring this closer to what they suggest. So let's go. Let's see. So that's 211, and that 20 volts, approximately 20 volts above what is called for is fine. I mean, that 40 volts may be fine for all I know. I'd have to figure out how to measure the current, and I don't know if there's an easy way to do that without breaking wire and putting an ammeter in there. Plate. Well, there is a possible way that I could do this. I think I could do that. I could find, there's a coil, an RF coil. The plate voltage goes up through it. If I were to measure that coil and then measure the voltage drop across it, I could then find out what the current is. And that could tell me whether or not that tube is being overdriven or not. And I might do that. Well, I've decided that I really want to find out what the current is that's flowing through the 26 tubes. The voltages, when the resistance is set to what the field coil, admittedly an unhealthy field coil, but the field coil, actually the voltage that was dropping across the field coil was what they call out in the information here. So I'm assuming that that resistance is pretty close to what it was. The resistance of that coil was pretty close to what it's supposed to be. But anyway, so the question I have is, should I run this with the higher voltage. Because if I bring this down so that I'm reading 185 volts on that, which this is the one that's across the field coil, or what would be the resistance, the resistor that's replacing the field coil. If I bring this down to where that's reading 185, the plate voltage is 140 thereabouts. And so what I've done is, what do I want to do? Okay, I have to do some swapping around, I guess, because let's see, this will work. What I want to do is, this is going to be, yeah, this should be it. So this should give me the plate voltage. That's what I want to do. All right, let's do that. All right. I don't know if I can get this so that you can see what I'm up to, but let's see. I highlighted, this is the B plus line here. Okay, that's the coil that I want to read. This is the plate, so that's the RF coil. And the B plus that I measure here, of course, is going through that. I already know that, actually I measured, I think it was this one, 58 ohms. I've written it down, yeah, 58 ohms. So this coil is 58 ohms. So I can put one lead on here. Well, I can do the same thing that I was doing when I was measuring the resistance. I put one lead here, and then I go down here to pin 11, 13. Yes, okay. Pins 13 and 11 are tied together in the radio. And one leg of the B plus goes over here to this tube, and then to that one. But the other leg of this pair goes over here and goes up here and feeds through these IF coils. So I've already measured across the coil. Now I'm going to fire this up, and I want to do two things. I want to set this to the voltage that it would have, or yeah, to the resistance that it would have if the field coil were still functional, which will mean that meter should say 185 when everything's all set properly. And then I've got this attached to, yes, okay. So I've got that black wire is attached to pin 9, which it goes to ground right here. Pin 9 is up here, he's down there, goes to ground, which is where they tell you to measure the plate voltage for the 26 tubes from. They tell you to measure between, I think they said 11 and 9. So what I'm doing though is I want to know what the voltage is across this coil, or this coil actually, one of these coils. Maybe it's that one. I have to look at my chart and see if I've got the right tube in the right place. It really doesn't matter. The tube I've connected to is 58 ohms. I know that coil is, that's what the resistance is of that coil. I've got a red lead going to here from the plate of that tube. But right now I've got this connected to chassis ground because I want to know what the plate voltage is. And that's not essential in terms of measuring the current through it, but I just want to know what it is. I might jot that down here just to make note of it. Then I will switch this lead to here, and then I will be measuring across across this coil. In fact, if I switch this to here and there, away, and do this, if I haven't made a goof, 58 ohms. So 58.7 it says. Really? 58.6. Alright, we'll put 0.6 down. Close enough. But we're going to start out with, and we want you there. So we're going to measure the plate voltage that's on that tube. I'll just jot that down because I'd kind of like to know. And then I'll switch this to here and I'll read the voltage across the coil. But I'm also going to then, I'm going to go, so once I get that voltage, then I'm going to go back to this and I'm going to adjust this so that the voltage across this is higher, and it's going to drop the voltage, the plate voltage on those tubes. And I want to drop it down to around 20 volts. So I'll be essentially reducing that difference between what it should be and what it is by half, because it's last time I did this, I was reading 143 volts on here for that plate. So let's see what we got. All right. I want to take this and do this and this, then I should be able to check this one. That's millivolts, 210 millivolts. I mean, it's low resistance, but 210 millivolts? Huh. And 78 millivolts. 230. Really? Okay. Well, this makes it very interesting. Here. We'll call it 210 millivolts. Okay, I'm going to fire up my cheater software. And okay, so I want, well, let's kill that for now, because I'm at the higher voltage right now, 220 volts. So let's see. I don't know what that was. Something fell down. Alright, so I want to, so I've got, let's see, I want to know amps and ohms. So yeah, that's what, so I've got 58 ohms, and I've got milliamps. No, I got millivolts. I'm in the wrong place. Current. Volts, ohms, millivolts. Okay, that's what we want. So 210, and our ohms are 58.6 to be precise. Okay, so what you've got is, okay, so we've got 58 ohms, 210 millivolts, 3.5 milliamps. The information on that is not available in this documentation, I don't believe. I don't think it is. But the tube manual says 6 milliamps. is what you would expect. Now that's at the voltages they suggest. So, control must lie in the radio set. I'm looking at a chart here and I'm trying to voltmeter. There it is, I found it. Okay. I have too many papers floating around. Okay, so I've got, so the grid voltage on the 26 tube should be supposed to be 9 volts according to that chart. And so let's see what our tube manual tells me. 26. Plate volts 180, grid volts negative 14.5. Plate milliamps is 6.2. They don't, I think that's pretty much what they give me. So the plate voltage on this tube is lower, which makes sense. That's why the grid voltage is lower. It's not negative 14, it's negative 9 in one chart and I think negative 6 in another. So this means that tube is okay. Okay, so we're going to change this to 60 and we change this to 77. Okay. 4.6. Alright, we'll back out of that now. What this means, okay, so when I have this set to 185, the millivolts is this, and this is the ohms for that, and it's 4.6, we'll call it 4.6 milliamps. MA. Alright. And this one was 221 volts, 210 millivolts, that was a different tube. That was 58 ohms, we'll mark that there. And that one was, I didn't write that one down, oh yeah, 210. Yeah, so that was 210 millivolts, that one. So, the difference in voltage, because this one was at around 240 volts on the tube, on the plate of the 26 tube. Not the same exact tube, I should have checked that, although I think I did. Anyway, so this is 221 volts across what was the field coil. It was 58 ohms, 210 milliamps. No, millivolts actually. Millivolts. And that was, we'll call it 3.6 milliamps. Okay. So, both of these are within range of what the tube manual says this can handle. So that means that even if I have my original speaker in here, and I was producing 185, dropping 185 volts across the coil, I'm still not exceeding the current capability of that tube. Why the numbers are so far off, I don't know. I turn that off. I'm going to just disconnect that so I know. I have a bad habit of forgetting to check where things are connected, and it has been the cause of blown amp meter fuses, because I tried to measure volts with it still on amps, and as we all know, putting a short across some voltage supply doesn't work well. So I still don't quite understand why the voltages are so much different than what they call out. However, this gives me a whole lot more peace of mind, because I know now that in the worst case scenario, this tube is not going to be pushed above what the tube manual says its max is. I'm pretty sure that's the max number, because they told me what the max plate voltage is, 180. And then all the other numbers, I believe, are based off of that. The bias voltage and the current. So, I think I'm all set. I'm learning a whole bunch of stuff on this radio, and I'm definitely enjoying doing so. There's a lot of stuff between talking with a fellow radio guy with 30 years experience and learning stuff from him, and learning stuff as I play with this. It's been really interesting. So, this is being inserted into something I previously recorded. So, I will mention later on in the video that it was from this good friend who I got the idea of checking the plate current the way I just did. And you'll see me do it again for the 45 tubes, because I don't want to overstress the tubes. And I have options. I could put a buck transformer on this and reduce the voltages down, and I actually did use my variable transformer, and I brought this down to 105 volts instead of the normal 120. And because the plate voltages are high, it didn't bother it in the slightest, but it did get the voltages more in range. Although even I believe that the 45, which you'll see me play with that shortly. Right now I'm measuring 280. When I dropped it down, the voltage down to 105, I believe the voltage dropped down to 230. Oh, and here's something interesting, and I don't know for sure, but one of the things he mentioned, and I didn't think about this, but the meters used back in 1929, 1930 were probably 1,000 ohms internal resistance. Now, our meters today are mega ohms, and I don't think they tell me. They don't. Yeah, they don't tell me. But the internal resistance of our meters is much higher, so that they are much less likely to draw the voltage down. Now, I recently got my hands on a little Lafayette meter, and that says it's 2,000 ohms. And I may check voltages one of these days. I've got to do some repair work on that one. But I may do some voltage checking using that one to see just how much it impacts the voltages, and if that meter brings the voltages within range of what they're calling out here. It's definitely an interesting idea, and I definitely I really want to try to see what I can do with that, or explore that. I really want to check that out. But so, what do? I know I could buy a 3K ohm resistor and throw that in there, and from everything I see, it would be fine. Well, that sets my mind at ease, and next you're going to see me playing with the 45 tubes, and I'll let the video, as previously recorded, explain that to you. I got this idea from talking to a friend who is very, very knowledgeable about this stuff. And he said, you know, if you're worried about the plate voltage on your 45 tubes, what you might want to do is, if I can just focus on this so I can show you what I want to show you. Let's see. Okay, right there. This is the output transformer. This is the primary side. These are our 245 tubes. So what I did is I measured across this winding and across this winding, and I made note of the resistances of both of these. I turned the radio on and I measured the voltage across both of these coils. And I have up here the voltages and the resistances. So between pins 4 and 3, 283 ohms, and that particular 45 tube, oh, stop it. Which one are you beeping at me? Yeah, stop. So, and it depends on which tube you're using. I have a newer tube and it draws a lot more current. So these older tubes are not drawing the same amount of current, which is fine for this application because the chart, the tube chart, tells me that the 45 tube at 275 volts plate voltage should be running around 36 milliamps. This particular tube, because it's drawing 11 ohms through this, is 38 milliamps. This one is 34 milliamps because it's only drawing 6 volts, 6.7 volts across that resistance. And I've swapped tubes back and forth playing around with it, and I think this may be my best bet, although I may swap these two just to see if I don't know if I paid enough attention. But anyway, this is only 2 milliamps higher than what the book calls for. So I think, well, let's just look and see what we've got for plate voltage. And that is 279, which is not horrible. 282, okay. That's a bit higher than I want, but the plate current is not that bad. So if I had to, what would I do? What could I do? Down here, this is the resistor. These two filaments, which are also the cathode, come down here into this winding, and then the center tap comes out here and goes into this resistor, which then goes to ground. And that's a 770 ohm resistor there. If I were to change the resistance there, I could affect the bias here. So if I were to increase the resistance, I'd drop more voltage across this resistor, and that would increase the bias, and that would affect the current flowing through both tubes. Actually, it would, both of them would be affected. So the one that's not drawing all that much current, well, relatively lower current, 24 or 24.6 or 24, that one would drop, but so would this one as well. So that would be one way to try to deal with the current flowing through these tubes. Given how it's performing, I don't believe there's a problem with that. It's definitely not distorted. I don't know what's playing right now, but let's see. Can't listen to that too long, much as I might want to. I've got lots of volume, not too surprising, got lots of plate voltage, but I don't have any distortion. It's playing beautifully. It's doing what it's... As far as performance goes, it's working great. Everything's working, you know, it's probably working as well as this radio is going to be able to work. I say that. I've got capacitors that I want to replace. A box of capacitors here, one here, and that thing down there. Talking to somebody, one guy that has refurbished more than a few of these radios, suggested that I mount a terminal strip and put my capacitors in. Oh, that's kind of long. Not too bad though. Mount the capacitors outside the box. It'd definitely be a lot easier. Because you've got 1, 2, 3, 4, you've got 8 tabs that you'd have to unbend. I'd have to take this out to my garage, take all the tar out of it, and remove the contents, and then mount the new capacitors. So, it's nice to have them hidden, but I am not so sure I'm all that excited by taking this. I don't know if you can see what's going on down there. Let's zip in on it, and I will show you. This wasn't doing it as badly as this when I first started playing with it. This radio those capacitors are not healthy. Now there's no heat that I can feel, but that's a massive box. And it really looks like something's getting warm inside there. So I got to figure out what I'm going to do there. I haven't decided yet. It's definitely an interesting idea to just mount a terminal strip down here and put some new capacitors in there. One of the headaches I'm going to have, though, is the capacitors that this uses are there's a 5, a 2.5, and a 3, and those are going to be pretty good sized capacitors. I don't think I have any. This is a 1 microfarad paper, and I want to use, I was thinking that I wanted to use these because my original plan was to put them inside the box and the size wouldn't matter. But if I were to use electrolytics, which I could put them outside the box. The reason I wanted to use these inside the box was that I didn't want, if you have electrolytics inside of something like that, you'd have to go through the trouble of unlatching all of those 8 tabs and taking that out and taking it apart. And these tabs will break off if you bend them too many times. They won't like it. So that's another reason not to put electrolytics inside there, because you could wind up not being able to mount your box. Or if you happen to own a welder, you could weld the tabs back on and then fit it back together that way. But I don't want to do that. I don't want to play with it. I could fix it that way, but I don't really want to. So definitely now I'm wondering, do I want to do that? Now that I see how big the one is, I had some others that were 2 microfarads, and I can't remember how big those were. But this is just a 1 microfarad, and it's huge. That's my thumb. It's big. So trying to mount those here, that would be a problem. So, yeah. Definitely got to do something about that. Not sure. I think I might. If I mount the capacitor outside the box, then I think I could probably get away with mounting electrolytics there, because it wouldn't be a huge deal if I did that. And I'm kind of thinking I want to do that because there are lots of good reasons. Oh, I was going to do this. We were going to check and see what resistance. Okay, 3.8. I think at one point I put down 3.9. Oh, 3.7 was a previous, one of my previous experiments with this. I'm actually going to use that number because I actually wrote down the milliamps required, and that'll tell me what wattage I need for that replacement resistor that I'm going to put in here. Let's go over here. 360, 330, 107. This should be 0. No. Yeah, okay, that's ground, I think. So we're up over 300 volts. I don't know. I didn't measure. I should probably measure that voltage as it's coming up. Now that it's warm, it probably won't tell me what I want to know. But I want to just see what this does when I bring it up. I think one of these is high. Yeah, that was 400 volts when it popped up. Of course, it's kind of warm, but I don't think it's going to go much higher than that. So if I did a 450 volt capacitor, that should work. So I guess my plan is, I think I have a plan. I got ordered the resistor that I want for that. Get the capacitors. Oh, I gotta find out what these are. Those are not that big though. Okay, I'm going to wrap up here. Because if I keep going, I just keep yammering. I'm wrapping up. Hopefully you enjoyed it thus far, and hopefully you'll join me again. If you liked it, let me know. Leave a comment if you're so inclined, and of course subscribe if you liked what you see. Thank you.